This problem has three separate unrelated parts. Let's start with part one. Here's the equation. To solve this equation, I subtracted sine x from both sides and then isolated the trigonometric function. Since the problem is only asking me for solutions between 0 and 2 pi, it's simple enough, based on my knowledge of the unit circle, that the sine of 3 pi over 2 is the only thing, in that interval anyways, whose sine is -1, thus completing the first problem. Let's take a look at the second problem. 3 pi over 8 is not one of our common 16 favorite arcs on the unit circle, but I drew a picture of what it would look like anyways. It terminates right about here, and it's not hard to imagine that 3 pi over 8 would terminate 3/8 of the way to pi, or slightly under half, thus justifying the picture. But again, this point is not one of our 16 points on the unit circle. So I can't really find the sine of 3 pi over 8, at least without a calculator. Now the sine, of course, is the y-coordinate, and I found the y-coordinate on a calculator, not because that's what you would do, you would solve this problem without one, but because knowing that there is a specific y value there is a good frame of mind going into this problem. So that purple mark on the y-axis, that y value, is the sine of 3 pi over 8. And whether we know its decimal equivalent or not, we know it exists as a decimal. But we want to solve this equation. The sine of something equals that y value. Well, one thing crossed my mind. If I were to take a point across the y-axis as a mirror image, wouldn't that point also have the same y-coordinate and hence the same sine value? So this arc right here that terminates in quadrant 2, directly opposite 3 pi over 8, would also be a solution to this problem, because the sine of that arc would also equal the same number as the sine of the 3/8, 3 pi over 8. So if I can find out what that arc is, I'll have another solution. Well, it occurred to me that that arc would be 5 pi over 8. If you're wondering where I got that, watch the diagram and I'll share the thoughts that went through my head. I simply counted by pi over 8s. Watch the unit circle. 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8. And just to confirm, 6 pi over 8, 7 pi over 8, and 8 pi over 8, also known as pi, terminating there. So thinking of the unit circle in multiples of pi over 8 is what led me to the conclusion that 5 pi over 8 was the mirror image point of 3 pi over 8. So now I know that because I'm only looking for solutions between 0 and 2 pi, that 5 pi over 8 is my only other solution. But wait a minute. Obviously, 3 pi over 8 is a solution to this equation as well. Plug 3 pi over 8 into this equation and convince yourself it's a solution. Of course it's a solution. We may not know what the sine of 3 pi over 8 is, but we know that it equals itself, don't we? Let's move on to the third question. The third question gives us an equation, and you might have thought, I should solve that equation. But because of the cosine cubed, I'm not convinced that you, nor even I, have the technical knowledge to solve this equation. But the question isn't asking us to solve it. It's asking us a true or false question, whether one interval has more solutions than another. But these two intervals contain the same numbers, except for their endpoints. The only numbers contained in the first interval that are not in the second interval are 0 and pi over 3. So the question of whether the first interval has more solutions than the second interval comes down to the question of are either 0 or pi over 3 are either of the endpoints solutions to this problem. So let's find out. What I'm going to do is I'm going to plug in 0 and see what happens. First, examine this work after me plugging in 0. You'll see that 0 turns out not to be a solution to this problem. Let's examine pi over 3. Plugging pi over 3 into this problem and doing all of the nasty algebra, which I'll let you hit pause and examine yourself if you'd like. Doing all the nasty algebra shows, in fact, that pi over 3 is, in fact, a solution to this problem. What are the solutions to this problem? I don't know. I'm not sure I could find them very easily, nor probably could you in this course. But simply knowing that pi over 3 is a solution to this problem confirms that this interval has more solutions than this interval. And thus this true-false statement is true. And that completes the problem.